Looks like we're just about there. Welcome back, everyone. And it's official. I think we can start. So for today's class, I did make a mistake before I came to work, actually. You can see it on my penmanship here. I forgot my digital pen. It's okay. We can still do class. It means I'll type out a few things. But if it comes to drawing, it's just completely off the table. I'll have to do it on the blackboard here, anything that we have to draw, which is kind of unfortunate. It won't make it to the notes. But I'm going to come back to these notes, and anything I put on the chalkboard, I'm going to put it back onto these notes before I upload them so that it looks like we typically expect them to. So today I'll be kind of just running around between here and here, making it happen. But before we get started then, folks, any questions so far? Okay, well, with what we have so far, we're nearly done with section 2.2. 2.3 is going to take a little bit longer. We're probably going to finish that on Thursday. Then when we come back on Thursday, we'll see our new quiz posted down here, quiz number 2. It won't be due on Monday this time. This is an exceptional week because we also have Labor Day holiday. We definitely deserve a break. So already we have a holiday on the line. Well, any questions, folks, with any of those announcements? Okay, well, let's see where we were at in section 2.2. Really, the main thing we're trying to achieve in this section, which is a really short one, is just understanding a bar chart, understanding how to construct it, and relative frequency as well. All we did for relative frequency on this table was we took each one of these frequency labels and divided by the table total of 1,268. So just a reminder on the context for this one. The idea here is, it says an automobile marketing firm conducts a study to see what types of cars people owned before they bought an American car. So there's 1,268 people that did in fact buy an American car, but the people who market are paying very close attention to what did you drive in? What are you trading in or something like that? What was your prior car? They're trying to find that out some way, somehow. Our data file in the Excel file that we looked at was completely gibberish. All we could tell is loads of American cars, which makes sense. If you're buying an American car, you possibly already had one prior. But then when we had the frequency given on this table, it makes a little bit more sense. There's twice as many Japanese cars than there were American cars. But if we want to be more precise with that, we convert this into a relative frequency where we're essentially looking at percents. Just shift the decimal point 2 places to the right. So that would be about 60%. Any questions at all, folks, on constructing that table? Okay, so once again, if you were the person who was in charge of this marketing firm and you came to the car dealership with this table, that's not too bad, but people are still going to demand graphics of some kind, which is reasonable. It's easier to just visually see at a glance and instantly see how all these different car manufacturers are related, even better than percentages. So let's make that our next step. I'm going to move this over here just so we can see. Oh, I guess I can't quite put anything. Oh, geez, what did I do? Sorry, just struggling with the Microsoft file. Okay, ordinarily I draw it right here, but like I mentioned, I forgot my digital pen today. So let's do it on the chalkboard. It'll be just a little bit different. And I will put the graphics on the notes here, probably sometime before class on Thursday. So before getting started, let me make sure we can actually all see everything at once. Work the classroom, that'll help. There we go. And my goal is to make it so we can still see the projector and the chalkboard. Doesn't get any dimmer than that. How's that look to folks? Is the projector still readable? Okay, awesome. So let's give this a try then. First thing we want to do is, for a bar chart, just make one extended horizontal axis, and then you're all set. Now, we indicated we want to use relative frequency. So our vertical axis going here, let's label it just that, relative frequency. So we'll start with just those axes. Next thing we should do is set up the vertical scale just a little bit better. When it comes to relative frequency, the highest you could ever achieve is exactly a 1. So that ought to be the maximum going up here. Let's just mark this off by say going 0.1 values. So here's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, I'm just about gonna make it, 0.9, and 1. Really didn't have to go all the way to the top since the highest category we see here is really this one at 0.5594. So if you stopped at 0.6, you're still gonna have a really great display. So really all we're gonna do, as the name implies, is just draw a bar, kind of the nicest display we have to do. So we'll put down here, American. So that'll be one category for our categorical variable, previous car owned. That one's at 0.5994. So I'm just gonna draw a height, really just a touch below this height right here. So it'll look like this for the first bar. You can make it look pretty if you like, shade it. If I was to shade it, I was probably just do it really quickly like that. And now we have our first bar. Then we're just going down the line. Let's move on to the next. The Japanese, we're at just barely below 0.3 for 30%. So let's add our label, Japanese. And this one's going to be right about at this height. Then pretty much let's just go down the line. Next one up is Korean. For the Korean makes, we have a relative frequency of 0.0292, so about 0.03. Already we are extremely low here. There's 0.1. So if I'm going to draw this one, oh, sorry, let's say again. Oh, thank you, 0.0568. I'm going down the line. Thanks for the help on that one. So 0.0568, not so bad just yet. Just a little bit higher than half this height at 0.1. So now it's getting a little bit tricky. But as long as your graph looks about right, I'm not going to get a ruler out and try to measure to see if it's exactly there. Just try to make them all in about the right ballpark. I understand doing it by hand. So here's the one for Korean, just a tiny blip. Now it's getting smaller and smaller. That was 0.0568. Now we're at 0.0292. We're going to make this just a touch smaller. Okay, so next we're at German cars. And 0.0292, about a height of 0.3. Probably pretty hard to even see it on the chalkboard. So just a tiny little blip there. So there's my next one. And last, other, the catch-all category. So plot this one, let's see here, it's at 0.2. It has to be shorter than this one, which is about 0.03. I'll make it look about like this. It's a very ridiculously short category. And there we have it. That's our pretty roughly drawn bar chart or bar graph. Does that make sense to folks on constructing that there? Okay. And web design is honestly a lot easier because they're multiple choice. They have no way of accepting a hand-drawn answer. But I would still encourage you to do these problems in web design. Give it a little try, just doing it by hand. That way you can see immediately which one's the right graph on the multiple choice. But even more importantly, when we do this on, say, either a quiz or an exam, it would be by hand drawing. So you're practicing two things at once. Any questions about folks on producing that? Okay, so again, the whole idea was we had an Excel file with hundreds of rows there, about 1,200 and some change. So all the information is now right here. So these are the previous cars everyone had at that sample when they bought an American car. So let's now finish off this file here. I guess I'll leave that on. Let me know if it gets just a little too dim to see text that's printed up here. So let's see what we've done. We've constructed the bar chart using relative frequency. If we use just frequency, all that would change is the vertical axis. But the heights of the bars and the relative heights from one category to the next it would look exactly the same. It would essentially have the same shape. All we did is normalize getting essentially percentages going this way. Now it says comment on the bar chart using the context of the study. I'll try to always make a really big deal out of this word right here. When it's referring to the context of the study, we have to some way, somehow include everything above here when we go to give the response. We need to mention we're talking about the previous car ownerships for people who bought a new American car. Aside from that, there's really not too much we have to put in here. Just take a look at the graph and say what pops out at you. Any volunteers for the first big thing that might pop out? If you're not sure, I would say maybe things to focus on when you're commenting on the display is, how about the tallest category? Certainly everyone would want to know about that American cars were overly, hugely represented here. It looks like it has more than about 60% of all the cars in this entire category. And looking at the graph, that tall bar chart, we could say something along these lines. People who bought American cars had overwhelmingly, let's say, let me try to make this more dramatic. People who bought American cars were highly likely to already own an American car at about 60%. So that's one thing that would pop out immediately at us. The marketing firm would probably give advice to the car dealership that, well, if you want to sell more American cars, maybe start marketing in slightly different, say some things about these other car makers, for example. So one thing that's kind of tricky about this is it said comment on the bar chart. It didn't say what kind of comment or how many comments. Really, it's just about say something and practice using the context. We used the context when we said buying American cars, and we weren't just talking about the heights of the bar on the bar chart. We were mentioning the original study. So if this was the question in part D on either a quiz or an exam, I would consider that full credit. I didn't say mention 2 different things or 5 different things. As long as you use the context some way, somehow, you'll get credit for that. Any volunteers for adding anything extra if you'd like to? Okay, how about one more just to finish it off? Another thing that would kind of strike me about this display is Korean, German, other, they're essentially, well, very, very minimally represented. Altogether, they account for less than 10% if we were to add these up. So we might say also, people, moreover, people who bought American cars are extremely unlikely to have a Korean, German, or other car previously owned. I capitalized other car because I'm really talking about this category here, other. I don't necessarily know which cars those was since they didn't tell us in the study. So to me, that'd be a pretty good response, probably more than I even expected. If it said on the question here, mention at least 2 things, that'd be a next great thing to talk about. Talk about what the largest categories are, talk about maybe how they compare one to another. You might say Japanese cars is important, but looks like it's less than half of what's represented in America. You could really write out a whole book on this. But again, keep in mind, if this was an exam 1 question, it is time, so try to limit your responses. So it's not too wordy. You can get to the other problems in a reasonable amount of time. But we did it, folks. That's our graphic. Sadly, I forgot my pen, so I'll just leave the text there and I'll update, bring this back to the Word file after class, probably before Thursday's class. First, any questions at all, folks, on completing this one? Okay, well, class looks different when you're standing up. That's really weird. Let me go back down to my normal posture. And let's save these notes down here. Okay, well, we did it, folks. Really, that's about what you can expect from section 2.2 on bar charts. You might have to actually plot something by hand on a quiz setting or potentially an exam setting. And so it's good practice to do it like we did here, even with the web assign as well. But let's now go to section 2.3, dealing with numerical data. Let me pop that one open. I really picked a bad day to forget the digital pen. I don't normally do that. It was just kind of a rush today. It's a bad day because we're drawing a lot of stuff, so I'll have lots of stuff to come back and correct. Well, when we were dealing with data over here, this was one categorical variable, previous car ownership. These were the categories that we had here. And this just counted the relative frequency for each one of those categories. But now when we go to numerical data, the situation is very, very different. For numerical data, like with what we have right here, we're supposed to give a display that captures these values. We want to see where do they all fall? Where do they accumulate? What are the unusual features? If we do a graph right here. Now, if we took all these numbers and put them in a histogram, this is about what the histogram would look like. It's not correct. This is a different study, but it would look about like this right here. So that's our typical histogram. Now, if we look at the bar chart versus the histogram, there's some really big differences. Notice there's no gaps here. In a histogram, a gap, like what we see right here, means there's no data. Data is missing between here, about 7.5, and here, maybe 7.6, 7.7, or something like that. So we have missing data in this location. But another thing that's interesting about a histogram is this is the real number line, and it has a specific order. You can't change that. You can't put 7.8 right around here. That'd be madness, right? But the bar chart's different. On this bar chart, there really is no order, really. It's common to go to the highest category and work your way down, but that's not a convention. That's just a nice way to do it, especially for comparing things. We could have reversed it. We could have made this come first and worked our way up, or we could have put the American in the middle and made a completely different shape. So when it comes to these bar charts, these things have no inherent shape. And the reason being is the categories, they have no order whatsoever. But for numerical data, there is order, the order of the real number line by that red dot. You march up from 7.0 to 7.8 or whatever your data was, and you have to keep it in that order. So there's no inherent shape on a bar chart. I should say that right here. But when you go to the histograms do have shapes that we'll discuss. Later on in the notes, we'll discuss the shapes along the lines of being symmetric, skewed either to the left, skewed to the right, unimodal, bimodal, all those weird words. I'm trying to describe the shape of that. And it's something you can do because every numerical data set will give you a unique shape like this. The world is extremely different going from categorical with the bar chart to finally numeric with the histogram. Any questions about that so far? Okay, now here's the tough thing about the histogram. I mentioned this last class. I'll never make you plot this by hand. It takes a good amount of work to decide what are the categories, how far should I go for my width on every rectangle. It's such numerically computationally intensive to do by hand that it really will only be done through computer software. When you use a histogram, it'll essentially already be printed out. The good news is histograms are tough to produce by hand, but other things are not. Now, one of them is the dot plot. So before we study these kinds of things, let's get a feel for them by doing this dot plot down here. Well, any questions first before we start working through this example? Okay, well, here's the setup. It says the following data on violent crime on Florida college campuses during 2014 is from the FBI website. So very real and serious data. Let me highlight this right here. since that's the major part of the context. So number of violent crimes reported, here is where all the numerical data is. So really, I only have one variable. This would be numeric, but would you consider this discrete or would you consider it continuous? Exactly, that must be discrete because you can't have, say, 2.5 violent crimes. That'd be weird listing in the FBI website. We'd probably question them. Yeah, half a murder makes no sense whatsoever. So here we're dealing with discrete data. So it says here, construct a dot plot using the 15 observations on the number of violent crimes reported. So our dot plot is a way to get something that looks like a histogram, but can be done extremely fast. Well, let's get started. I'll put it here on the chalkboard. When we're doing a dot plot, first thing you'd want to do is just throw down a horizontal axis. So let me start off going this way. There it is, that's good enough. If this was a quiz problem or an exam problem, I'll probably print this for you just to help out. But it's good to know how to do it just for the sake of practice on our own. Now, next thing we want to take a look at is looking throughout all these categories, we need to know the minimum value and the maximum value. Let me put it here. Just as scratch work. So the minimum value looks like, yeah, Pensacola State College had 0 violent crimes. That's awesome. Go Pensacola. I don't know their mascot, but how about for the maximum? 29? Yeah, right here. University of Central Florida had a lot of violent crimes. We shouldn't hold it against them because it says Central Florida. We don't know how big that one is. That could be a humongous campus. It could be, say, 30,000 students, maybe more. So I don't have the per capita crimes. I just have the actual numbers themselves. So be forgiving for that campus, University of Central Florida. And now we have these, going back to the dot plot we're producing here. Let me actually label that. First thing I want to do is put a tick mark that's going to include the minimum. So that gets us started. Now I don't want to count these off as 1, 2, 3, 4, 5. That's just way too many tick marks, right? We'd be here all day. So instead, we're going off to 29. Let's say count by 5s. Does that sound reasonable to folks? Yeah, we'll get us there. If we're doing, say, more than 12 tick marks, maybe count by a higher number is a good idea. So we'll go here for 5. 10, 15, 20, 25, and right here I can stop at 30 since we've gone beyond the maximum. So we now have a good range to plot everything right over. Now this next step is going to be a little bit weird for me, but I'll do my best. All we're going to do is go down the line, and every time you see a value, we're going to place a dot. So, well named, it's a dot plot. So we're placing dots to represent the data. First one was at 3, and I'll put it, say, right here. When it comes to a dot plot, you don't actually put the dots on the axis. We just let it float a little bit above to show where it would be represented. Down here at 3 violent crimes. And we just now move on to the next ones. Does that make sense to folks so far? Okay, then going down, let me know if I skip over one. Next one, it was at 10, so I'll place a value here. Down the line, we have Florida Atlantic University, so 5. But now something weird happens. We have a repeated value. The next university was Florida Gulf Coast University at 5. When we have a repeat, we just stack the dots. That's how we're going to show how concentrated data is, maybe right around here. So there's our next value. And then just continue on down the line. Making sense to everyone so far? Okay, folks might be a little bit faster than me, but I'll run through it. Next, we have 9. So just to the left of the 10. Down next, we're up to 15, Florida State University. So way over here. Then a 2 and a 0 and a 1. Let me just put those down. So 2, 0, and 1. Already, I'm more than about 3/4 through the data set, roughly. And we can see data is really accumulating right on this end. That's good. That means a low amount of violent crime. So we like to see it accumulating on this end. Let's see what else we have. My next value is 29, and it goes way, way over here. Would you agree that this one just feels odd? It's just completely skipped away from the main body of the data that was over here. But let's continue on and we'll come back to that value here. So down the line, I have 15, 4, 15. So 15s are popular. Here's my 15. 4 can be scrolling right here. Another 15. And last one, University of West Florida had 6 violent crimes in 2014. Sounds grim, but it's serious data. That means it's important for sure. But there we have it. That's our dot plot. Any questions at all, folks, on that construction there? Awesome. They're pretty fast to produce. It's kind of relaxing in a way. And the way it's similar to a histogram is all the histogram is telling us how many observations fall inside a range. So say this one says 5 observations fell between about 7.1 and 7.25 roughly. Those actual values there on that horizontal axis didn't fall on nice values. Here we can say a similar kind of thing. There's a lot of data falling into this location. It kind of spreads out a little bit more. We get a little bit of blip of concentration here, and then nothing until we're way, way out here on that far observation. So it's just telling us where all your data is ending up, giving you a sense or a feel for the shape of that data. Well, any questions at all, folks, on constructing that dot plot? Okay, well, now that we've done part A, I'll just put here, well, I guess I'll leave that blank and I'll fill it in later. Let's now go to the part B. It says, comment on the dot plot and use the context of these data. Let me highlight that in yellow. This is always the toughest part when they're mentioning context. It means when we go to give our response, we have to be talking about violent crimes in Florida, college campuses. You don't have to bring everything into the context. So if you didn't say during 2014, I'd say that's okay. We can carry that in. We just have to know what did these numbers actually represent. So that's what we're meaning by context. Okay, so we're going to comment on the dot plot. It's tricky at first. It's kind of like commenting on the bar chart. You need to know what are the things you might want to say. But when it comes to numerical data, there is some pretty good guidance for this. I'll put here center, and we can put for our response on this one, the observations for the violent crimes in Florida universities is, well, if we say center, we're meaning where is everything concentrated? So we'll say is concentrated around. Then we're going to do something kind of uncomfortable. We're just going to eyeball it and pick a value. So when you're looking at this dot plot, what number along the horizontal axis would you say is closest to the most dots? Sorry, say again. 15 is pretty good because it's close to these three. It's vertically aligned. But by close, I mean kind of a lot of dots around it, not necessarily right above it. So what number would you say has a lot of dots around it? Said a little bit better on my part. I would agree with you on 5. If you're looking around 5, then go a little bit to the left, a little bit to the right. You captured a lot of observations. If you're saying right around here, there's nothing right around here. So it looks like with the list of universities they gave us, about 5 violent crimes in 2014 was the typical number. I don't know how they got the sample, but if it was a random sample of Florida universities and campuses, you could say that's typical for every Florida university or campus. But let's go here and say observations for the violent crimes in Florida universities is concentrated around 5 crimes. So always the center is a really good thing to mention whenever you're dealing with a dot plot. And again, it's uncomfortable. We visually estimated about 5. What we'll be doing in the next section is chapter rather, is we'll pick up a calculator, put the data inside it, not the dots, and we'll just have it calculate the average for us. The average is going to be the center. And what's kind of remarkable is when you guess visually and then put it in a calculator, you're often very, very close. It's kind of magical almost. So center is a great thing to mention. Any questions so far? Okay. Any volunteers for something else that we ought to mention as well? Absolutely. This one observation, it just looks funny, right? And anytime you produce a display and something just looks weird, you always want to mention the weird. I like how you said outlier. This is what we mean by an outlier. It's way away from the main grouping of data. So let me put a quick note here. I would say that the main grouping of data is right around here, whether you include these 3 dots or not. And so when we look at this one, this is an outlier. Since it is far away from the main grouping. Now, I underline this word far because the question you might have now is, what did you mean by far? I haven't quantified that at all. It's all just visual for the moment. That looks far away to you, then call it an outlier and then mention it. But later on in chapter 3, we'll have a rule for this, the 1.5 IQR rule of thumb. It's just a rule of thumb, but at least it gives us some measure of when do we think things are far or when do we think they're close. So let's mention that right away, the outlier. Okay, and you didn't necessarily have to format with center here, outlier there. More that's just for organization of the notes, giving an idea of good things to mention. So we'll say here, there is one unusual observation of 29 violent crimes for, let's look it up. 29 violent crimes was University of Central Florida. The University of Central Florida. And if there's any Floridians who end up watching this YouTube video, keep in mind that we're not really saying anything bad about University of Central Florida because the safety or the dangerous level of any one of these campuses depends on student body size, right? I don't know what the per capita numbers are. This could just be a really large university like we mentioned earlier. And so they had more opportunity for a violent crime to arise. Pensacola State College, I don't know a lot about that one, but well, let's maybe do this one. New College of Florida is probably a small campus. And so it should be very minimal, around 0 or 2 is what I expect. But if we're just taking a look at the values collected, then in that context, 29 is highly unusual, even though we may have an explanation for it. Other questions so far? Okay, so we've mentioned the center, we've mentioned an outlier. Let's throw in one last thing, the spread. Oh, first question? Sure. Oh, sorry, I thought that was a question, my mistake. Let's go to spread next. Spread is something we're going to calculate later on, and we're going to see it done in a couple ways. We're going to calculate a standard deviation, or maybe our interquartile range. We'll see how all that's going to be done. But if we're doing everything visually, what we mean by spread is essentially just this. From here to here, this is the spread. It ranges from 0 violent crimes to 29 violent crimes. And that's helpful information if we're summarizing a data set through these graphics right here. So we can say here, all of the violent crimes in this data set range from 0 to 29 crimes. So we did it, folks. This data set wasn't really large like we've seen before, the one with about 1,200 and some change observations. But even with a small data set like this one, 15 observations, it is hard to get a feel for what's the typical value, what's an outlier, until it's displayed as a graph. It kind of just presents everything. Values are accumulating around 5. The 29, it may look unusual to you as you read through here, but now it absolutely stands out when you're looking at the graph. It just helps the reader get a feel for the data. And we'll do a little bit better with spread. Giving the range is informative, but maybe not super informative at the moment. And we'll be able to do a little bit better later on. But we did it, folks. Yeah, go ahead.
This asking us to comment on it, should we, like, every time we do one of those?
Oh, not necessarily. This was more just extra organization for us. If you did a comment on this and all you said was, say, just for emphasis, all you gave me was this, I would say that's okay. We're really just getting started with commenting on these kinds of displays. Does that help out? Gotcha. Although I would say, now that I've said that, formatting it like this is not a bad idea because we're going to be talking about center, spread, and outliers quite a lot. So it was also kind of a heads up in a certain way. But if I wanted that kind of actual output for the answer, I would have had to say it in the actual instructions, or else the question would be unfair. And that's kind of what's going on way down here, describe shape, center, and spread of these data. So we'll kind of answer this question in those lines. Other questions at the moment? Okay, so that's producing a dot plot. And now we want to turn over to dealing with issues with histograms next. Histograms are a little bit tricky. And so I put this here just as an example so we could look at a histogram right away. The way we can connect a histogram to dealing with a bar chart, or excuse me, a dot plot is, think of breaking up this graph right here into just certain ranges. Much like what we see up here, where it's partitioned from about 7.0, 7.2, and so on. We may say from here to here, be a grouping, this a grouping, and this a grouping. Then we could add yet another axis. And just count how many observations lie on each segment. This has 1, 2, 3, 4, 5. I'll let 5 go to the next one. So we might give this a height of 5. That'll be our first one. The next window, I'm including the 2 dots above 5, but I'm not going to include the dot on 10. I have 1, 2, 3, 4. So this one will be a height of 4. And then so on. We could produce our histogram kind of in this way. Next range, 10 to 14, I'd have a height of just the 1. So it would look like this. Now 15 to 19, we're at a height of 3. So 1, 2, 3. Roughly about here. And then finally, a height of 1 just in this location. So that's about how the histogram would look like for our original data. And that's the histogram for just some other totally unusual stuff. The main takeaway is anytime you put your finger on any one of these rectangles, it's telling you how many people belong to that study, 2 in this case, who had a pH from about 7.3 to 7.5. So that's what the histogram is trying to convey. Same idea as the dot plot, except here you don't see the dots. You just know that there's 5 observations in this range from here to here. Does that make sense to folks? Okay, we'll look at this display again later on. Sorry, go ahead.
So I just have a question. The range seems pretty random. What is it that actually determines what the range is? That just seems really arbitrary.
Just the smallest value to the largest value.
Right, but I mean, like, why is it broken up the way that it is?
Oh, on this right here?
Yeah, like on the.
Oh, gotcha. There's a complicated formula for getting the actual
That's to make
width
them
of
sort
these.
of Same width.
Yeah, they wanted the same width, and the computer software that did this also wanted to kind of convey where the main peak was on the data and anything that was breaking away, like this one here. So computer software just ran through a bunch of formulas and produced everything. Here, I just decided go from 0 to 5, 5 to 10, and so on. And not the most sophisticated way, but still gave us a picture. Other questions about that? Okay, well, let's now take a look at issues about histograms. Now, once we start dealing with histograms, sorry, I scrolled a little too soon, like this one, I mentioned they all have a shape. So every time you collect numerical data, the question might be, what is the shape of your data? That's extremely important because for getting used a statistical procedure, doing inferential statistics, if your data is bad enough, they'll tell you what procedures are just not going to work. We want data that looks symmetric enough. This is pretty symmetric. It's not perfect. It's kind of eking out an observation to the right, but it's not too far away. That one there was extremely far at 30. But this right here would be considered absolutely not symmetric at all. This is horrible data. The asymmetry is when it trails off going this way, and these data would be extremely hard to analyze. We can't use the normal statistical procedures. They would all just fail right away, depending on the sample size. So let's now take a look at these definitions here. My goal was to put pictures here. I'll do them on the chalkboard and then upload them later. I picked the worst day to forget my pen. Any other questions at the moment first? Okay, so first I want to look at histograms that would be considered unimodal or bimodal or multimodal. When we say modes or modal, we're talking about the main peaks of the data. Unimodal means there's just one single main peak where all the observations are. And that's what's happening on this one right here. That's the main peak, and this would be considered unimodal data. So let me draw just a couple histograms so we can get a feel for what does other unimodal graphs look like, what would a bimodal graph look like, and so on. So let's put them, say, over here. Let's do a histogram that starts off looking really pretty nice. There's one main peak right here. It trails off going to the right. It kind of trails off drastically at first. Then for no apparent reason, let's say we had just a tiny blip right here. Therefore, it fully trails off and ends right here. So this is our first histogram. Pretend image right over there in the notes. Okay, if you saw this, this is a tricky question, but how many main peaks should we see here? Is it 1 or 2? Almost an uncomfortable question. Any volunteers for just a random guess? I heard 1. It turns out, yeah, absolutely. There is one main peak, and it's right here. Here's where the data accumulates the most. There's a lot of data around it. And this one is not a main peak. For this one to be considered a second main peak, it should look like this instead. A lot of data needs to be accumulated right here for us to call it a second main peak. But it's just a tiny blip. That happens while you're collecting random data. Sometimes you get just a little bit more by pure randomness unknown in this location, but it's really trending down. So this would be considered unimodal data. Only because it has exactly one main peak. Any questions about that so far? Okay, so that's unimodal. Let's take a look at bimodal very next. Now I mentioned this isn't bimodal because there's just not enough data aggregating right here. It's kind of like this 15. By randomness unknown, 3 universities accumulate right here. The major peak is really in this range. This is where the major accumulation is actually happening. But for something that is truly bimodal, it could look about like this. So here's another horizontal scale. I'll put some data around here. Say this time for our horizontal axis. The horizontal axis can sometimes be number of violent crimes. Up there, the horizontal axis was the pH of your joint fluid. That sounds morbid. But over here, let's say that the horizontal axis, let's give this one context, sugar. In cereal. So this will be the high end, this will be the low end. I didn't put any values here, but that's what the axis is going to represent. And let's say in white, this will be adult cereal. So all we're doing in this histogram is getting random boxes of what we consider adult cereal at least, and seeing how much sugar grams there would be per serving. Your histogram might look about like this. Maybe some of them are extremely low in sugar. You could have some stuff out here. Some of it might be a lie. You might have cereal that are way more sugar than you expect for adult cereals. And maybe even some of them that are just an outright lie. It could be values way out here. So that's half our histogram. And this is where bimodal really kind of takes charge. Sometimes we put all of our data together and there's a natural grouping. Say the adult cereal versus children's cereal. We'll do this one in yellow. So if we're to plot a children's cereal and this is sugar going this way, higher to the right, we're probably expecting some stuff to say emerge right around here. Some values can fall around to the left, to the right, like before. Some of these might overlap. So the children's cereal could be around the same amount as the adult cereal. It could even go uncomfortably close to the adult cereal. But this is now the picture of a bimodal display. There's a magnitude peak right here. And there's another main peak way over here as well. And it seems almost natural that there should be, because we're throwing all the observations together. When there is a natural separation, our data has a categorical variable together with a numerical variable at the same time. The numerical variable will be sugar content, plot here. But the categorical variable will be cereal type, adults versus children. So if you have a bimodal display where there is obviously a main peak here, a different main peak somewhere else, then there's probably other variables that you should be accounting for as well to separate things out. It could be, say, mass. Maybe you're looking at a species of fish. Some species will be more massive, some will be less massive. Or within just, say, a single species, you could look at just the sex characteristics. Maybe the females are more massive than the males or vice versa. And you can see that same kind of picture. Well, that's what bimodal looks like. Does that make sense to folks so far? Awesome. Now, it takes a lot of emphasis to get a feel for these kind of graphs. Like I mentioned, this one was not a main peak. It was just a blip. Likewise, on this display right here, that one would not have been a main peak. It was also just a blip. And also, we probably wouldn't even call it an outlier either. Let's maybe end on that idea. This one was an outlier because it was far, far removed from the main body of data. And we put an observation, say, right here on this one, there's just a tiny gap from where this is with the main body of the data over here. So we can say small gap. And this one would be not an outlier. Well, I forgot to look at the clock. Looks like we have less than 1 minute left. Any last questions or comments, folks? So I'm getting through these. Okay, well, I appreciate your patience today. Sorry if you had to swim to read everything, projector and chalkboard. I'll make sure to remember my 10 on Thursday's class. Well, have a great night, folks, and I'll see you all on Thursday.